Alright, for this video, we're getting into section 6-1 for Algebra 1. We're starting something new with systems of equations. So we need to talk about what kind of, what is a system of equation, and then what kind of answers we'll actually get when we solve something like this. So we're on Desmos for this one. If you guys can see on the left-hand side there, I have two equations written out. They're two linear equations, meaning for us slope-intercept form right off the bat. I have one highlighted right now so we can see that we actually do get a straight line when we graph it, and then I have another one kind of ready to show in just a second. So that first question I brought up, what is a system of equations? So a system of equation is any time that we're given more than one equation to solve at any given moment, meaning that we're going to attempt at least to find an x and y value that solve both of these equations, and for future reference it's possible to use more than two, but we'll start with just the most simple system, two equations right now. But an x and y value that solves both of them using the same x and y value. As we get further into systems of equations, there are multiple ways to solve these, but we're going to try to go one at a time here. And the first one we're dealing with, as you guys can probably see on the screen, is graphing. So if you're already okay with graphing in slope-intercept form, this probably won't pose much of a challenge to you. However, if graphing linear equations, something like we have here, is a challenge, this will at least serve as extra practice, but as I've shared with my Algebra 1 students, it does keep popping up throughout algebra. So let's kind of recap that real quick, or how we got this line. This -1 at the end here is my b value from slope-intercept form, y equals mx plus b. That -1 tells me where to start when I'm graphing. So from the origin at 0, because it's a -1, I go down 1. That's why I have a point here. That's why I'm crossing the y-axis right there. And then from that point, if we go back to the equation, my slope, or the coefficient here, is 1 over 2. That's a rise over a run. So from that point we just had down at -1, I'm going to have a rise of 1, a run of 2, meaning I go up 1, to the right 2. And that's how I cross the x-axis actually over here. So that's our red line. Now let's go ahead and take a look at our blue line. So if we see at the end, we have a +2. So from the origin, I start up 2. That checks out there. My slope is a negative, so I know from left to right, it's going kind of like a downhill. I'm going to have down 1, right 4. So having a fraction as the slope really doesn't change much for us. It actually just tells us our rise over run. From that point at +2, I go down 1, right 4. So now what we need to think about in order to solve this, that's what we're trying to do when we have a system of equations. We're trying to solve. That's the thing that's going to tell us when we're done, finding an x and a y value. And I mentioned there's multiple kind of options when we're solving this too. So with a graph, kind of like we have here, we can see that our two different linear equations actually cross each other at a certain point. If I click on that on Desmos, it's pretty nice. It actually tells me that that is point 4-1. So we know with an ordered pair, that's an x value and a y value. With systems of equations, that point where they cross, that's going to be the x and the y value that solve both of these at the same time. So if I think about plugging that in, if my x value is 4 and my y value is 1, let's actually write that out here. So my ordered pair was 4, 1, and then let's work through each equation here. Y is going to be 1, so I'm doing the red one first, equals 1/2. My x value from the coordinate where they cross is 4. I'm plugging that in, I'm substituting, and then minus 1. Okay, on the left-hand side I have a 1, but on the right-hand side here, 1/2 times 4 is 2. That's this. 2 minus 1 is 1. That one is solved. Okay, let's take a look at the blue one now. My y value again is 1 equals, now I have negative 1 over 4. I use the same x value again of 4, and then plus 2 at the end of this one. Okay, so my left side is going to stay as 1. Negative 1/4 times 4, well, that'd be like negative 4 over 4, which would give me negative 1. If this all gives me negative 1, which if that's something that you didn't see right away, you could check in a calculator, that's totally fine. Negative 1 plus 2 gives me a positive 1. Those are also equal. So that just shows that that point that I found, the 4 1 right there, that is my solution. So if you're given two linear equations or two equations in general, the point that they cross, that's going to be your solution. And that's the x and y value that you could plug in and find an answer. Okay, let's talk about a few more types of answers you may see before we wrap this up. Let's clear off here. So I'm going to use different equations now. So let's get rid of those for the time being. Okay, so let's take a look at something like this. Y equals, we'll do 2/3 x plus 4. Let's do plus 2 so it's in the screen. And then y equals 2/3 x minus 1, something like this. Well, if we remember from when we first learned about slope, things that have the same slope but different b values or y-intercepts, that same slope, the 2 over 3 in this instance, causes a set of parallel lines. And we can see that with the picture with the green and the purple lines that they graphed for us. We know from the definition of parallel lines what parallel lines are. They're two lines that are never going to cross each other. Well, our answer in the previous example was where they crossed, and we're never going to have that here. So what that means is when we're solving systems of equations, it is possible to have an answer that gives you no solution, or you could use a symbol kind of like that. Circle with a line through it. Okay, so that's an option. There's no other calculation that needs to be done or anything like that. And then let's show one more thing here before we wrap up. Let's do y equals 3x plus 2 and y equals 3x plus 2. You notice when I graph those, it only looks like one line. If I take away the red one for a second, you can see the black ones underneath there. That's because these equations are exactly the same, meaning that these lines cross each other at every point. So if before, when they crossed once, that was our one solution, and when they never crossed, we had no solutions. If they always cross, we're going to have infinite solutions. So that just means any x and y coordinate that you pick out that falls on the line, so anything that's on the line here, if you use those x and y values and plugged them in, it would solve both of them, and that makes sense because they're the same equation. So those are the couple options you'll see. Hopefully this helped. As we wrap up here, just want to encourage you to leave a like if this did help you. Feel free to comment if something didn't make sense to you or if there's something that could be explained a bit better, and subscribe if you haven't. We're going to get further into new material pretty soon. Alright, see you guys.